Introduction to the design and development of intelligent control of EV BMS application. In this product we are using DC motor and the battery pack, voltage sensor, this is the current sensor, voltage sensor, and this is the current sensor, and also using Arduino Uno, LM2596 buck converter, Raspberry Pi 0, and also using track PCB and LCD display. And also we are using a charging circuit for the battery pack. So here we can see it is 11 volts battery. So we can add this. So here we can see this is charging circuit for this battery pack. We need to connect this one, and we need to connect the transformer connection to the rectifier. So we are providing 230 volts power supply to the transformer primary side, and the secondary side it will be stepped down up to 9 volts that will be given to this input of the rectifier. We know the rectifier converts AC to DC, so it is converting 9 volts AC to 11 volts DC using this capacitor. That 11 volts DC will be given to this battery. So we can see light indication over here, which means battery get charging. So we need to charge the battery maximum 4 to 5 hours, then only it will be works good. Now coming to the 780 voltage regulate buck converter, it will take the 11 volts input and will step down up to 5 volts constant DC. That DC will be equally giving to this track PCB. So the main purpose of this track PCB is equally divide the 5 volts power supply to this all components, because these components will be works on the 5 volts of power supply except this DC motor. So this DC motor will be works on the 11 volts power supply. So now I am switching on this power supply right now here. So here we can see it is showing the welcome to the point, and also Raspberry Pi is on position, and Arduino Uno is also on position. So Arduino Uno will be calculate the ADC values of the current, and the Raspberry Pi will be used for the SOC and life of the battery calculation purpose. So now we can see here, so it is showing the SOC and the SOH, state of charge and state of health, and voltage and the current. So current will be shown whenever the DC motor is in on position. So we can see it is showing the 1000 milliamperes, which means 1 amp nearly. So if I close this one, so we can see 0, and also it will show you the life of the battery in hours. So we can see 1.46. So based on the Raspberry Pi calculation and that algorithm, it will be send a serial communication with the Arduino Nano. Then Arduino Nano will be send a values to the LCD display. So in this way this product will be works. Thanks for the watching.